So I will send out an email to the class so you'll know the instructions for the final exam and what I require from you for the final. So the same deal, you have to, I'm going to mention in the email, but I just want to say it one more time for those of you who are here. You're going to submit your written work to me the usual way. I'll send out the Dropbox link the day of the final, a couple of hours before. That way you have that on the way. And so the thing is, we're not giving partial credits on the final. Whatever you get right, that's your grade for the test. No partial credits. But you have to submit your answer so that you're justifying how you got to those answers. Without a justification, of course, no credit. So some of you, but looks like you're not here. I had a couple of students, they're not here, but I think it is worth mentioning that you don't pick a choice on a blackboard. That's a bad idea. You have to pick a choice. You have to submit an answer for every question. If there's no choice being submitted, there's no credit. So if you happen to be one of the students, please make sure for the final exam, you have to give me an answer choice on the blackboard, regardless of what you put down on your scrap paper, okay? So all of you do that, so there's no point in telling you guys are good. You guys have been doing great, so keep it up. Just keep doing what you're doing and just keep working hard. 2 more days and then summer break, so enjoy. All right, so having said that, well, what do you guys want to go over?
Can we do the spring 2019 final? We were supposed to do, as you said, like this review session, the whole spring 2019 final.
Yep, definitely. So I have it right here. Do you guys have any questions regards to the final exam, or should we just start with this? All right, so I'm just going to go ahead and start with this. So let's go ahead and start with, so which question do you guys want to go through? So hopefully you have the time to skim through this exam. It's a very nice test.
Go over question 9.
Number 9.
Yeah.
So this is a really nice test. That's 8. All right, so here's number 9. So let's do number 9. So for this question, we want to show that x equals 0 is a regular singular point. So take the limits or compute the Euler equation. The limits will give you the Euler coefficient, so same. And then we're going to compute the recurrence formula for the series solution corresponding to the larger root. All right, so let's do the first part of this. So we're going to take the limit. So we take the limit. Okay. I lost the question. Okay, so let's get to the question again. Right here. So we want to show that x not equals 0 is a regular singular point. So we're going to compute the limit. So the limit as x approaches 0 of 6x, x times 6x over x squared, and then 1 minus 2x. So I factor p of x as well. So if you factor this, this is just x squared times 1 minus 2x. That's p of x. And then this is our q of x, and the last function is the r of x. So if you take the limit, what do you get? So if you take the limit,
I get 6.
6, right? Yeah. So so x squares will cancel out. So you'll have 6 over 1 minus 2x. As you plug in 0 for x, you get 6. And this coefficient is actually one of our Euler coefficient.
Beta.
Beta. So let's call that beta, and it's finite. So let's move on to the next limit. Limit as x goes to 0 of x squared times, now we do r of x, which is 6 plus x over p of x, which is x squared times 1 minus 2x. And what is this limit?
Also 6.
This is also 6. Ooh. And that's gamma. So since both limits are finite, right, you just write a sentence, x equals 0 is a regular singular point since both limits are finite. Now for the second part, we're going to assume that the solution near regular singular point, it's going to be the form y equals the sum an x to the n plus r. And in expanded form, this is just x to the r times a0 plus a1 x plus a2 x squared and so on, right? So we compute its derivative, so y prime, it's going to be the sum n plus r times an x to the n plus r minus 1. And the second derivative would be the sum of n plus r minus 1 times n plus r times an x to the n plus r minus 2. And then we plug these, all of it, into the original equation. Oh, cool. It's long. So we have, I'm going to distribute the y second prime and then so on, and then distribute y as well. So we're supposed to get 5 terms. Okay. So we have x squared times y double prime plus, no, that's minus 2x cubed y double prime. And then the third term is plus 6x y prime. And the last two are 6 times y and then x times y. So we have 6 times y plus x times y equals to 0. And now we're going to substitute the summation into this. So let me know if you guys have questions.
Too big.
All right, so now let's plug in the second derivative. We have the sum n plus r minus 1 times n plus r a sub n. Now I'm going to simplify as I go along. If you input x squared into the summation, you'll have x to the n plus r, because the negative 2 and the 2 will cancel. Minus 2 times the summation of n plus r minus 1 times n plus r times an x to the n plus r, and the exponent will be plus 1, right? And the third one, we have 6 times the sum. Now we are plugging in the first derivative, so that will be n plus r times an x to the n plus r, because the minus 1 will cancel out. Can you guys see the brown, or should I change the color?
Yes, we could see it.
Okay. So I got up to the third term. Okay. Let me just make it smaller. And the last two, we have the sum an times 6 x to the n plus r. And the last term, we have the sum an x to the n plus r plus 1 equals to 0. Okay. All right. So we got some work to do for this one. So now let's look at these powers. So for the first one, we can just k be n. The second one, we have to let k be n plus 1. The third one, k is n. The fourth, k is also n. And the last one, k is n plus 1. All right. So what I'm going to do, I'm kind of rearrange them at the same time so that I have same subscript next to each other. So this one and this one and this one, we can put them together because they all have k equals n. So we have the sum So I guess this can go down a little bit more. Okay. So I'm going to just put them together. So we have n plus r, well, we're using k. So we have k plus r minus 1, k plus r, a sub k, x to the k plus r. And the next one I'm going to rewrite 6 times k plus r, a sub k, x to the k plus r. And the next one we have is plus 6 times the sum a sub k, x to the k plus r. And the remaining two, they also have same substitution, so that's pretty nice. So we have minus 2 times the summation. So now I'm working on this summation right here. I'm letting k to be n plus 1, so n will be k minus 1. So we have, so n is k minus 1. So that would be k plus r minus 2, and then we have n is k minus 1, so that's k minus 1 plus r. We have a sub n is k minus 1. And the last one we have, so this is the last one. That's going to be plus the sum. If n is k, sorry, if k is n plus 1, that means n is going to be k minus 1. So we have a sub k minus 1 x to the k plus r equals 0. All right, so that's a success. Now we just put them all together, factor out the coefficients, and write everyone has x to the k plus r. So we have the sum of k plus r minus 1, k plus r, a sub k, plus 6, k plus r, a sub k, plus 6, a sub k, minus 2, k plus r minus 2, k minus, well, k plus r minus 1, a sub k minus 1, and the last one, a sub k minus 1, everything times x to the k plus r equals to 0. And then we want the coefficient to equal 0, so I just hope this is visible to you guys. It's really hard to see. Okay. So now we want to solve for the highest subscript. So if I set all of this to 0, we have, so check this out. We have a sub k, which is, so a sub k belongs to this one, and this one. So I'm going to move the remaining one to the right. We have 2 times k plus r minus 2, and then k plus r minus 1, a sub k minus 1, minus a sub k minus 1, all over the coefficient of a sub k, which are k plus r minus 1, k plus r, and then plus 6 times k plus r plus 6. All right, so that looks okay, not so bad. We can do a little bit more on top, factor out a sub k minus 1, because that's in common. So we have 2 times k plus r minus 2, and then k plus r minus 1, minus 1, everything times a sub k minus 1, all over k plus r minus 1, k plus r, plus 6k, plus 6k plus r plus 6. All right, so we need to now find the larger root. So let's go back to our Euler coefficients, which we computed right here. So what is the corresponding Euler equation for x equals 0? So we know x squared y double prime plus beta xy prime plus gamma of y equals to 0. And we found the coefficients there, 6 and 6 for beta and gamma. Plug them in, so we have x squared y double prime plus 6xy prime plus 6y equals to 0. So that's the corresponding Euler equation. Now let's compute okay, so let's compute the initial equation. So the initial equation is going to be r times r minus 1 plus 6r plus 6 equals to 0. So we have r squared plus 5r plus 6 equals to 0. Can you factor this?
Yeah, r
Yeah,
plus
right? R plus 6 and, no, sorry. R plus 5. No, let's do 3 and 2. Yeah. So we have two roots, negative 3 and negative 2. All right, so from here, we're going to use the larger root. So the question says, compute the recurrence formula for the series solution corresponding to the larger root. So what is the larger root?
-2.
Okay, so let's use that. So coming back to the recurrence relation we got. So so this is really not visible. Okay. So using r equals -2, our a sub k, it's going to be, what is it going to be? So plugging in r equals -2, we have 2 times k minus 4 on top, and then r is -2, so k minus 3 minus 1, everything times a sub k minus 1 all over. Again, r is -2 also on the bottom, so we have k times -3, k minus 2 plus 6 times k minus 2 plus 6. And then, of course, this will simplify and really we'll have a nice formula. So on top, I'm going to distribute and combine. So what do you guys have? 2k squared. And then we have -3k and minus 4k, that's -7k. And then times 2, that's -14k. And then -4 times 3, that's 12. Times 2, that's 24. Minus 1, so that's 23 really. Okay, so we have 23. All of it times a sub k minus 1. And on the bottom, if I simplify, I have k squared and the -2 and -3k, that gives me -5k plus 6, and then plus 6k minus 12 plus 6. And then, of course, you can simplify this further. So we have a sub k is equal to 2k squared minus 14k plus 23, a sub k minus 1, all over. On the bottom, we have k squared plus k, and then 12, they cancel out. Ooh, nice. So there you go. That's the recurrence formula for the coefficients. Any questions on this? All right, make sense so far?
yes.
Okay, so now going back to the question, so we're almost there. So with a0 equals 4, compute the first 4 non-zero terms. All right, so a0 is 4. So if a0 is 4, so we're going to let k equal to 1. So that would give us the next coefficient. We already have a0. So if I let k equals 1, I have a sub 1, which is 2 minus 14 plus 23, a sub 0 over 2 on the bottom. Now, what are the numbers on top? So we have 2 and 23, that's 25. and then I'm going to subtract 14 to it. I think that's 11. So just double check my work, guys. And then A0 is 4, so plugging that in, we have 11 times 2, that's 22. Nice. So A1 is 22. If I like k equals to 2, I have A2. That's going to be questions? All right, so that's just background sound. Okay, so k equals to 2. Oh boy, so you guys do the calculation, okay? So that's, for the top, we get k squared, so that's 2 squares, 4 times 2, that's 8, minus 14 times 2, that's 28. 14 times 2, right? Yeah, 28. And then plus 23, okay, not so bad. And then a sub 1 all over. On the bottom, we're doing k squared plus k, so that's 4 plus 2, that's 6. All right, not so bad. So if I simplify the top, so 8 minus 28, that's negative 20. And then plus 23, that's 3. A sub 1 over 6, which simplifies to a sub 1 over 2. And a sub 1, we found that previously, that's 22. So that's 22 over 2, that's 11. Nice. Okay. And you got the idea. Just go for one more. You guys can figure this out. So you guys fill in k equals 3. That will give you a sub 3, dot, dot, dot. Fill it in, okay? Now, let's write out the solution. So our solution to this problem, it's going to be y equals x to the r times a0 plus a1 x plus a2 x squared, and so on. And then plugging an r and all these coefficients, our solution would be y equals x to the negative 2. A0 was 4. What was a1? That was 22. Plus 22x, and then a2 was 11, plus, and so on. So you're supposed to go for one more terms, but I kind of stopped because it's just plugging numbers in and doing the calculation carefully. You can figure that out, so why not, right? So there you have the solution. Okay, so any questions on this?
Professor, they said the first 4 terms, right? Do we count A0? I mean, do we count the term that they already gave us? Or do we have to...
Yeah, so this counts as a term. That's a term, that's a term. We needed one more.
Okay.
Yeah. So you start counting terms from A0. All right, so there you go. You have number 9 worked out. So any questions or any other questions?
Professor.
Yep.
So after we figured out the y prime, and the y double prime, what happens to the x squared and the minus 2x cubed?
Oh, so here's what happened. So when you plug in your summation into the second derivative and the first derivative, I'm simplifying as I'm going along. So if you look at it carefully, for the first term, right? If I substitute this into the summation, the x squared and this negative 2, you can add them up, and that gives you just n plus r. So that's why I have this power, because by laws of exponent, I can combine the powers as long as the bases are the same.
Okay.
You see that? Yeah, and then I did the same thing for the second and the third and the fourth. I didn't have to modify, and the fifth I had to modify.
Thank you.
Yeah. All right. So any other questions, guys?
We'll do number 1C.
Number 1C. Okay. So here is number 1. so that's something from the very past, right? All right, so how would you solve this problem? What method can
Variation
we
of
use?
parameters.
Yeah, right, because your g of t is secant square of 3t times 81. So we have to use variation of parameters. So first we need to compute the homogeneous solution, and then from there we can just pick up. So our YH, that's going to be, so this is another way to write Y double prime. You all agree, right? So we have Y double prime plus 9Y equals to 0. So that's the corresponding homogeneous equation. So the characteristic polynomial is R squared plus 9 equals to 0, which will give us R equals to plus and minus 3I complex root. So our homogeneous solution is C1 cosine of 3t plus C2 sine of 3t. Now we go ahead and compute U and V because we assume that the general solution is going to be Y equals U times Y1 plus V times Y2. So, all right, so U is given. Well, before that, let's label this function to be Y1, and let's label this one to be Y2. So then U is going to be the integral of negative G times Y2 over the Wronskian dt, and V is the integral of G times Y1 over the Wronskian dt. So that means we need to find the Wronskian before we start integrating. So what is the Wronskian by definition?
Gonna be y1.
So that's cosine 3t, and its derivative. So that's negative 3 sine of 3t. And the second column we put y2 and its derivative. So that's sine of 3t, 3 cosine of 3t. And then if you compute this matrix, you will have, what is the Wronskian?
3.
3. Right? Because you'll have a trig identity in the middle. Sine square 3t plus cosine square 3t, that becomes 1. Okay, so now that we have the Wronskian, we're ready to compute U and V. We have the negative integral of G, that's 81, secant square of 3t over 3 times y2, that happens to be sine of 3t dt. And now we want to simplify before we really get into the integration. So let me just have more space. Okay, so let's simplify this.
You could break down secant squared 3t as 1 over cosine squared of 3t.
So let's do that. So we have negative 81 over 3. Secant square rewrite as cosine square of 3t. And then here we have sine of 3t. And how do we integrate this?
Use substitution.
Yeah, right? A simple U substitution will do. So we have 81 over 3. I can write that as 27. I think that's 27, yeah. And then we use U substitution. So we have sine 3t and then cosine square of 3t. So, so let's pick W substitution because we're already solving for U. It looks silly to pick U, right? But really it's the code and code U sub from calculus. So W is equal to cosine of 3t. So dW is going to be, so if I differentiate, I get negative sine of 3t dt. Okay, that's kind of nice, right? So we already have the negative and the sine 3t. So all of this is just 27 integral of 1 over, I think I forgot something. Hold on.
Negative 3 sine 3.
Yeah, forgot the 3. All right, and then so this will be 27 over 3. and then 1 over u square du. Well, 1 over w, because I'm using w substitution, right? All right. So this would be 1 over w square dw. And then this integral will just be negative 27 over 3. That's just 9. W to the negative 1 plus C1. And then plug in what is W. That would be negative 9 over W. That's going to be cosine of 3t plus C1. So that's our U. And now let's compute V. So V is going to be the integral of G times Y1 over the Wronskian. So G is 81 secant square of 3t. Y1 was cosine of 3t. The Wronskian was 3 dt. So again, simplify, right? So I'm going to rewrite secant square. So 81 over 3. Let's simplify that. So if I do, so I can rewrite secant as 1 over cosine. So that would be cosine square of 3t, and then I still have a cosine of 3t on top, and I can cancel out one of the factor of cosine, so that's 27, 1 over cosine of 3t dt. Okay.
Professor,
Yeah.
for you, shouldn't it be positive 9?
Positive 9. Let's check. Well, the negative is coming from the integration, right? So if I rewrite this, so this was 9, and then this is the integral of w to the negative 2 dt.
Okay, I see it.
Okay. All right. So now here, now let's think about this. How do we integrate 1 over cosine? So what I'm going to do, I'm just going to rewrite it as secant. So this is 27 integral of secant of 3t dt. Now this is an integral that you should remember from calculus. Do you guys remember what this integral is?
ln absolute value of secant 3t plus tangent 3t plus c.
Over 3, right? So we have 27 over 3 times ln of secant 3t plus tangent 3t plus c. So that's our v. So now we just put this together and multiply it with plus c2. Let's use c2. So we put all of these together with the solutions u1 and u2. So we have our general solution. So let's put all of this together. So far we have y is equal to u times y1 plus v times y2. So we have u, which we computed, negative 9 over cosine 3t times, well, plus c1 times y1, which was cosine of 3t, plus v, which we just computed, so 27 over 3, that's just 9. 9 times ln of secant 3t plus tangent 3t plus c2 times y2, that's sine of 3t. And now just distribute and collect your particular solution in homogeneous. So if I distribute, we have c1 cosine of 3t plus c2 sine of 3t, that's y sub h, and the rest will be particular solution. So we will get negative 9 over cosine 3t over cosine 3t. That's just simply -9. And the last one would give us, oh, forgot the absolute value. We have plus 9 sine of 3t times ln of secant 3t plus tangent of 3t. So there you have your solution. This would represent y sub h, and all of this would represent y sub p. And together they are the general solution. Yeah, I couldn't make a box, sorry. Looks funny looking shape, but there you go, we have the solution, so that's all matters.
Professor.
Yeah.
Can you tell us the solutions for A and B so we could check?
I didn't do it. Well, why don't you tell me, what did you get?
So for part A, for the first one, I got tangent inverse of y over x equals to ln of absolute value of x plus c.
Like that?
Yeah. And then if you want, you could take the tangent on both sides and
Yeah, we can
simplify it further if the answer choice is that.
So how did you approach this problem? Which method?
Homogeneous.
Yeah, right? It's first order homogeneous.
Yeah.
So if you just, so I'm just gonna start you off. It looks right. So if we simplify, this is 1 plus y over x plus y over x squared. And then you use the substitution, let v equals y over x, and then ... right? Fill in the rest. Looks good. I would say looks good. If anyone else worked it out, you can also share your answer and compare.
Got the same thing.
I got the same thing.
Yeah, great. So we have a couple of you, so we'll take that as an answer. I didn't work it out, so I wouldn't know, but it looks good.
Will this format be typical of what we'll see on the final, or would we have to work this out further?
This looks reasonable answer, but if you had to go and find the explicit solution, you would do tangent inverse, you would do tangent on both sides. So if you want the explicit solution, that would be y over x is equal to tangent inverse, not tangent inverse, just tangent, because it's already inverse, of ln of x plus c, and then multiply by x. So y is equal to x times tangent of ln of absolute value of x plus c. So more algebraic work, but any of these, you should know how to modify them and somehow match it up with the choices you have. And Sadia, you mentioned another one. Was it 2?
Yeah, so for the part B, I got half ln absolute value of 2y plus 1 is equal to half ln absolute value of 1 plus x squared plus c.
Plus c is outside?
Yeah.
Okay.
So you could take e on both sides and go more further if you want to get the explicit one.
Right, so you can multiply by 2, get rid of the 2, and then take exponential on both sides, blah, 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 right?
Yeah.
Did anyone else get the same answer?
I got the same thing.
Okay, so Bethany also has the same answer. So what type of equation is this?
So let's see, what did I use? Separable.
Separable. How did you separate them?
So if you look at the negative 2x plus y is equal to x, right? And you move the x on the left side, you could factor out an x, basically.
Okay, so let's do that. So we have 1 plus x squared. I'm just going to write y prime instead of dy dx. and then minus 2xy minus x equals to 0. Factor out the x, we'll pull out a negative x.
Yeah.
So that would give us y plus
2y
1.
plus 1. 2y
Mhm.
plus 1.
Right. And then we have 1 plus x squared, y prime. Yeah, looks like it's separable.
Mhm.
Yep. So if you continue, you would have y prime equals x times 2y plus 1 over 1 plus x squared. And then just rewriting y prime as dy dx. This is separable. All right, good work. Yep, I would agree with the answer if I continue. But I think you guys can figure out the rest. All right, so any other question you guys want to check on?
Do you guys want me to do tell you the answers for 2 and the other ones?
So did anyone work on number 2? So Sadia, why don't you tell me what you got for number 2?
Okay, so the first one, it's an exact, like the method you're gonna use is exact. And if you use the exact method, you're going to get the general solution. You're going to get c is equal to y squared plus e to the x cosine of xy. And then you could plug in the y of 0 is equal to 3. So if you plug that in, that equals 3 equals. Okay, let me just do this part.
Okay, so if you plug in the initial conditions, what do you guys have? You have c is equal to, so y is 3, that's 3 squared, plus e to the 0, cosine of 0. So that would give us c is equal to 9. So I don't know if any of you have this.
Professor, isn't it 10? Yeah.
10. How did you get 10? Oh, right. Sorry. Oops. Typo. So this is 10. Right, because e to the 0 is not 0, it's 1. So all of this is 1. All right, so.
I got the same thing.
Yeah, okay. Thanks for checking in, Bethany. All right, so looks like this is the answer for 2. Again, I didn't work it out, so I wouldn't claim this as my answer. But it looks reasonable, so I will go with it. But the key idea of this problem is to test that it is exact. It looks like in that form, so you want to show the partial of m respect to y is equal to partial of n respect to x. Now, which component is m and which is n?
E to the x cosine xy minus y sine xy is the m. And then the 2y minus e to the x times x sine xy is the dy, which is the n.
So this would be the n. And then if you take their partial derivatives, you will show that this is true. If it is, then you proceed with the exact method. All right, moving on to the next one. So that's a second order non-homogeneous. So which method are we going to use?
Undetermined coefficients.
Right, so we use undetermined coefficient. And what will be the solution if you worked it out?
Y is equal to -4 plus 2 e to the -5t plus 5t plus 2 e to the 5t. Yeah.
Okay. Did anyone else get the same answer? Now, let me know if you guys need me to work out any of these problems. I'm leaving it completely up to you guys to tell me.
I got something different.
You got something different.
Yeah, I had -5 plus 3e to the -5t plus 5t plus 2e to the 5t. So
Okay.
it's just the first number.
Yeah, so it's only the coefficients are a little different. Okay,
Could
so
you
we
do this
have,
question?
yeah, let's do it. So we have two possible choices. So we compute the homogeneous solution first. So we have y double prime plus 5y prime equals to 0. So we have r squared plus 5r equals to 0. So r is equal to 0 and negative 5. Okay, so our homogeneous solution is c1 e to the 0, that's just 1, plus c2 e to the negative 5t. Okay, now we figure out the form for yp. So for yp, we need a constant and a constant time e to the 5t. So we need a constant, but this constant is going to overlap with our homogeneous solution, so we multiply by t to make it independent from YH. Plus, now the second part we need a constant time e to the 5t. Let's call it b e to the 5t. And this doesn't overlap with the homogeneous, so no need to modify. Okay, now we compute its first derivative, second derivative, plug everything in to the original. So yp prime, that's a plus 5b e to the 5t, and yp double prime, that's 25b e to the 5t. So we plug these into our original function. We get y double prime, that's 25b e to the 5t, and then plus 5 times y prime. That would be plus a plus 5, 25 b e to the 5t, and then on the right side we have 25 plus
25 plus 100 e to the 5t.
Okay, thank you. All right, so now we can kind of equate the coefficients. So we have 5a is equal to 25, so a is equal to 5. And then the second, we're going to equate these coefficients to 100 e to the 5t, so that would give us 25b plus 25b is equal to 100. So we have 50b is equal to 100, hence b is equal to 2. Okay, so we have our solution. Y is equal to the homogeneous, which is C1 plus C2 e to the negative 5t plus the particular, which was AT, A was 5t, plus B, that's 2 e to the 5t. So that's up to the initial condition. And now, if you apply the initial condition, y of 0 is 0 and y prime of 0 is also 0. So let's do that. So we have y of 0 is 0. So that would give us, so if I plug in 0 for t, we
You
have
would just get C1 plus C2 and then plus 2.
C2. All right, plus 2. Okay. And then if you, so yeah, we can't really solve it yet. So let's plug in the second condition. So compute y prime, we have negative 5 C2 e to the negative 5t plus 5 plus 10 e to the 5t. And now we can impose the second condition. Y prime of 0 is 0. So that would give us 0 is equal to, plugging in 0 for t, we have negative 5 C2 plus 5 plus 10. All right, so, okay, that's nice. We can solve for C2. So what is C2 equals to? We have 5, so 15, so subtract 15, and then divide by negative 5, that's 3. So C2 is 3. So if C2 is 3, plugging it into the first equation, C1 is going to be, so 3 plus 2, that's 5, negative 5. So it looks like the solution I got is y equals C1, which is, what is C1? Negative 5, plus C2, that's 3 e to the negative 5t, plus 5t, plus 2e to the 5t. So that will be the solution to the initial value problem. Let's check. So it looks like the second one is the correct answer. So Sadia, do you see what went wrong with your calculation?
Yeah, I didn't add the 10 with 5.
Oh. All right, so careless mistakes. Okay, yeah, that's it happens, right? It happens to me a million times. So, yeah, but just be careful, okay? Heads up, be careful, super be careful. These questions can be really long. You just have to practice and be careful that you don't make these mistakes, like silly ones, especially. Okay, so that was that. Any other question you guys have, or you guys would like to go over?
Professor,
Yeah.
for the final, will you be giving us partial points as well, or is this all different?
So far from what I heard from the department, there's no partial points on the final. Whatever you get on the blackboard, you must justify them by showing me your scrap work, and that will be a grade for the final test.
Okay.
Yeah. All right. Yeah, any other
Professor,
questions?
can you
Yes.
do number 3 and 4?
3. Here's 3. Okay. So let's do a tank problem. So we have a 500-gallon tank initially contains 100-gallon, keyword initially contains, in which are dissolved 50 pounds of salt. Okay. The tank is flashed by pumping pure water into the tank at a rate of 3 gallons per minute, and wool mixed solution is pumped out at a rate of 1 gallon per minute. All right, compute the time when the tank has filled. All right, so let's do one at a time. So let's write down what is given to us first. So we're given VI, or V initial, which is 100. I think in class I called it V sub 0, right? Maybe. I'm not sure.
Yes.
But, so they all mean the same thing. V initial, V naught, initial amount. Which, so we have 50 pounds of salt. Which component is that?
The initial concentration of salt.
So that's
Q of
the
0.
Q of 0, which is 50 pounds of salt. Okay, and then now we set up the scenario. We're pumping in pure water. What does that mean?
Cn is 0.
Cn is 0 because it's pure. And the rate that it is entering the tank is 3. And it's well mixed, pumping out at a rate of 1 gallon per minute. So we need to figure out what is C out. Well, C out, we said, what was the formula? It's V initial plus the rate slope, which is rate in minus rate out, times T, right? It'll depend on how much coming in and how much exiting the tank. So our C out, it's going to be 100 plus R in is 3, R out is 2, so that's 2 times T. Okay, now we can set up, well, before we set it up, let's compute the time when the tank is filled. When is it filled? How do we know?
And the tank reaches the capacity of 500 gallons.
All right, so we want to reach 500, so 500 is equal to V initial plus,
Professor, I think the formula that you have for C out is supposed to be the formula for V of T.
Yeah, sorry. I put the actual formula down there. That's the V of t. And C out is going to be, that's going to be the other formula, right?
It should just be Q over the volume formula, right?
Mm-hmm. So that's the formula I wrote down earlier. And here you have the amount. So it's the amount over volume. That's concentration out. All right, so sorry for that typo. So now, when is it filled? Well, when we reach the capacity, which is 500, so that's V naught plus Rn minus R out times T, which we already computed earlier. That's V of T. So we have 100 plus 2T equals 500. So what is T? 200? Yep, okay. So we know when it's going to be filled, when the time is 200. Now, the next part, we want to write down an initial value problem, which describes the amount of salt in the tank at any given time before it is full. Okay, so we want the differential equation dq dt is Rn Cn minus R out C out. So this would be, so this part will go to 0 because concentration in is 0. R out, that's 1 times C out, that's Q of T over V of T, which happens to be 100 plus 2T. That's our model. With the initial condition, Q of 0 is 50. So that's the model for this scenario. And we're going to use this equation to compute the concentration of the salt in the tank at the moment when it is filled. So how do we find that?
Professor.
Yeah.
Shouldn't it be negative QT over 100 plus 2T? Because R and C and minus R out, C out.
Yep. Forgot the negative. So negative. Yep, absolutely. Thank you. Thanks for the catch. Okay, so so for this last part, we want to know the concentration of the salt at the moment when it is filled. So how do we find concentration? So we want the concentration when it is 200, right? So that would be Q of 200 over the volume, that's 500. So that will give it to you. So any questions on this problem? Any other questions?
Can you solve the differentials part?
Yeah.
Do
So
we have to do that, or we could just leave it like the way we have it?
So in this question, it says use the equation to compute the concentration. So it doesn't really say to solve it, right? I wouldn't solve it because it doesn't say it. If you don't see this as a choice, right? Because it's a multiple choice test, then you want to go ahead and solve it, find the actual amount when t is equal to 20, and then plug that in up here, because that would be the amount when the tank is filled up. So let's go ahead and solve it, just in case we wanted to know how to solve this. So if you were to solve this, you have dq dt. Which method can we use to solve this?
Separable, right?
Yeah, so this is, you can use either separable or linear, but when the concentration in is 0, you don't have to use integrating factor, you can just do separation of variables. So if I do separation of variables, we have dq over q of t is equal to dt over 100 plus 2t. And now we can just freely integrate both sides. We have on the left side ln of q of t, and on the right side we have ln of 100 plus 2t over 2 plus a constant. And then we go ahead and exponentiate both sides. We have q of t, that's going to be, so if you exponentiate both sides, you get 100 plus 2t to the power 1/2 times c, right? And now we can plug in the initial condition. So q of 0 is equal to 50, which means 50 is equals to, so when t is 0, we have 100 to the 1/2 power, so that would give me 10. And c is going to be then 5. So we know our model q of t is going to be 5 times 100 plus 2 times t to the power 1/2. And if I want to find the amount when it is full, we just have to plug in t equals 200. So q of 200.
Wait, I think you lost the minus sign.
I lost the minus sign where? Oh yeah, I did. Damn it. Okay, let's fix that. So shouldn't take us so long. Right here, negative, negative, negative half. Oh, that will make a big difference. All right, fix it. So we're okay up to here, right?
Yeah.
Okay, now I'm gonna plug in the initial condition. Q of 0 is 50. So that would give me C, well, 50 is equal to C times 100. T is 0 to the negative 1/2. So that would be 1 over 10. So 500 is equal to C. Yep. Yeah, I think that looks good. Okay, so now we know our Q of T. That would be 500 times 100 plus 2t to the power negative 1/2. And now we can plug in 200. 500 times 100 plus 2 times 200 to the power negative 1/2. And is this a nice number? Not really, right? So let's just rewrite it. So we have 500 times 400 time at 100, that's 500 to the power negative 1/2. Oh, this is kind of nice. We can add them up. So we have Q of 200, that's equal to 500 to the power 1/2. So that would be the amount when it is full. So if I want to substitute this into this formula, that looks like the color, you will have the concentration when it is full, right? You guys follow?
Yeah.
Yep.
I think it's
Okay.
500 to the negative 1/2.
Oh, negative 1/2. Why? Oh, right. If you simplify, right? Yeah.
Yeah.
Absolutely right. Because on the bottom we have a 500. So all of this will simplify to. So we have 500 to be positive 1/2 over 500, and if you simplify this, that's just 1 over.
Wait,
5.
Professor.
Yeah. What happened?
For Q of 200, why do you only have 500 to the 1/2?
Q of 200. Why do I have 500 to the 1/2? Oh, I combined these two.
Oh, okay, I'm sorry.
Yeah. No, it's okay. You're checking on me because I've been making a lot of mistakes. I'm not careful enough, but thank you. Really appreciate it. Okay, so yeah, you can do a lot of work and then simplify this out. We get more simplified answer. But the idea is explained, right?
Professor,
Yep.
could you, if you don't mind, can you solve it in the linear method?
This one? Well, it would be linear if you had a concentration in, right? And if you don't have concentration in, separable is easier. But if you were to go for linear, you would have something like this. So you would have dq dt plus 1 over 100 plus 2t times q of t is equal to 0. And then you know mu of t is going to be this guy right here, right? E to the integral of that dt and blah, blah, blah. Do you see it?
Yes.
Mm-hmm. But every time you see concentration in, or if Rn or Cn is 0, then separable would be the method to go by because it's much quicker to get the formula. Whereas if you use integrating factor, you're going to end up doing integration for mu of t and then probably integration at the end as well. So I would just stick to separation of variables if Cn or Rn is 0. Okay, so any other questions?
Can we do 7B?
7. Okay, so this is 7. All right, so we have a spring that is stretched 18 inches, which is 1.5 feet, by a mass of weight 600 pounds. So for this one, we just want to set up the initial value problem, which describes the motion of the mass neglecting friction when the weight starts from rest. So we start from rest at the equilibrium position and subjected to an external force of that much. Okay, so what are we given? So we have the weight. Do we have big L?
Yes.
Yeah, right? So 1.5, let's convert that to a fraction. Okay. So let me just rewrite. Sorry, I'm trying to fix this color. Okay, so if I convert this is just 3/2, right? You don't have to, you can use 1.5 if you want to. So we have the weight, which is 60, and we have big L, which is 3/2. It's already converted for us. So we have to find M, we have to find K, and we have to find gamma. So M is going to be what? What was the formula? The weight over
Gravity.
right. So what is the gravity we're going to use for this problem?
32.
Right, so 60/32. And then K is going to be, what's the formula for K?
W/L.
And then if you plug these in, you have 60/3/2. And what's gamma in this problem? Doesn't
0,
mention?
not given.
Right, it doesn't mention, so we are going to assume it's 0. So we have M times U double prime plus gamma times U prime plus K times U equals G of T, along with the initial position and initial velocity. So what are the initial conditions for this problem?
U of 0 is 0.
So U of 0 is 0 because you're starting from rest, And it doesn't mention if we're applying any velocity to it, so that would also be 0. Now let's plug this in. So we have 60 over 32. So if you want, you can simplify that. You double prime plus k, 60 over 3 over 2. So that's 120 over 3. That would be,
40.
I think that's 40, right? Yeah. That's 40 times u is equal to g of t, which would be 5 cosine of 7t. Yeah. So there you go.
How did you get the u of 0 again? Equals 0?
So this is 0 because we are starting from rest.
Right.
That's why this is 0. And then because it doesn't mention if we're applying any initial velocity to the mass, that will also be considered 0 as well. All right, so any other questions, guys?
Can you do number 4?
Number 4. So here's number 4. So for this question, we want to compute the recursion formula
It's open.
for the coefficients centering x not equal 0.
No, it's okay.
So we're going to assume the solution. So we're going to assume that the solution is the sum an x to the n, right? Because we're looking at just ordinary point. And its first derivative, this is not visible. Okay, so y prime, that's going to be the sum n times an x to the n minus 1. And then the second derivative, it's going to be the sum n times n minus 1 an x to the n minus 2. So let's plug these in, and we're going to distribute at the same time. So we have 2 times the first derivative, so that would be the sum n times n minus 1 an x to the n minus 2 minus, now I'm going to again do the same thing like we did earlier, push x to the fourth inside the summation of the second derivative. So that would give us the sum n times n minus 1 an x to the n plus 2. And then the next two, we have 2 times the sum. Again, I'm going to push the x inside the first derivative summation. So we have n times an x to the n. And the next one we have is 4 times the sum of the first derivative. That would be n times an x to the n minus 1 plus 2 times the sum of an x to the n plus 2 equals to 0. So that's the setup I have. All right, and now we're gonna move the powers, so we're gonna shift them. So we use the variable k to substitute for the powers. For the first one, we're gonna let k to be n minus 2. Second one, we're going to let k to be n plus 2. Third, k is equal to n. And the fourth, k is equal to n minus 1. And the last one, k is equal to n plus 2. So then we have the following. We have 2 times the sum. So if k is n minus 2, n is going to be k plus 2, and n minus 1 will be k plus 1, a sub k plus 2, and we have x to the k. So I'm holding on to that term. Actually, let's Let's write it out for now. Minus the second summation, we're letting k to be n plus 2. So we have n is going to be k minus 2. So k minus 2. And then n minus 1 would be so let me just double check. K minus 2. So that would be, so n minus 1 would be k minus 3, right? And then a sub n, that would be k minus 2. Okay. And the next summation we have, so x to the k. We have 2 times the summation. So here k is n, so not so bad. And the last two we're going to get is negative 4 times the sum. So if k is n minus 1, n is k plus 1, a sub k plus 1, x to the k. And the last one we have 2 times n is k, sorry, k is n plus 2. So we have a sub k minus 2, x to the k equals to 0. All right, so that's what we get by shifting the summation and the powers. Now, so you can see that they all have x to the k in common. So I can pull out all the coefficients and then set them equal to 0. So we will have the sum 2 times k plus 2, k plus 1, a sub k plus 2, minus k minus 2, k minus 3, a sub k minus 2, plus 2 times k, a sub k, minus 4, k plus 1, a sub k plus 1, plus 2 times a sub k minus 2, everything times x to the k equals to 0. And now we solve for the highest subscript among all. So that's going to be this term right here. That looks like the highest one. Okay, so our a sub k plus 2, it's going to be, so if I move everything else to the left side, right side, we have k minus 2. And then we have k minus 3, a sub k minus 2. Then we have, so I'm just gonna match up the subscript. This one and this one, they have same subscript. So we have minus 2, a sub k minus 2. And then we move the last, the middle 2. That's minus 2k, a sub k, and then plus 4, k plus 1, a sub k plus 1. Everything over the coefficient of a sub k plus 2, that'll be 2 times k plus 2 times k plus 1. That's the recurrence relation, but we can simplify this so that it's easier to find the coefficients. So we have a sub k minus 2, and the coefficient of that is going to be k squared minus 5k, and then we have a positive 6k minus 2, that's positive 4. And the last two don't match, so we're just going to rewrite them. 2k a sub k plus 4, k plus 1, a sub k plus 1, all over 2 times k plus 2 and k plus 1. So that's our recursion formula. Okay, so any questions on this? Make sense? All right, are you guys there?
Yeah, it makes sense.
Okay. All right, so now that we have our recursion formula, we want to find the series solution, compute the first 3 non-zero terms. So y of 0 is 12. We know that's going to be a0. and this is A1. So we have to go for 2 more because we only have one non-zero term. Another one is 0, so we have to go for 2 more. So if I plug in k equals 0, so if we plug in k equals 0, so if k is equal to 0, so check this out. If k is equal to 0, we have a sub 2. So on top, we're going to get 4 a sub negative 2. And then the second one is minus 0. And the last one would give us 4 times a sub 1 all over 2 times 2 times 1. Well, we know negative subscripts are 0. So we only have, well, we also know A1 is 0. That's given. So this coefficient doesn't survive, right? So 0. You have to go for the next one. So if I like k equal 1, we have a sub 3. So that would give us a sub negative 1 times, so k is equal to 1. So we have 1 squared minus 5, that's negative 4, plus 4, that's 0. So this is 0. Minus 2 times 1, that's 2a sub 1, plus 4. K is 1, so that's times 2. A sub k is 1, that's 2. Well, looks like this is also going to be 0. This is 0. This is 0. This is also 0. So this coefficient is also 0. So we have to keep going. So did you guys work this one out? Which one survives? So do you guys know what is A4?
I think it's negative 1.
Negative 1. Okay, so this one survives. What if k is equal to 3? That's a sub 5. Is that non-zero?
From what I have, yes. It's negative 4 over 10.
Okay, so let's take those. So do we have 4? Well, we're looking for 3, right? So we have 3 non-zero terms. All right, so I'm going to take these as an answer. But again, it's just calculation, plugging in k values into this recursion formula. And just do it carefully. So I'm going to take those and write out the solution. So our solution is a power series. We have A0 plus A1x plus A2 x squared plus A3 x cubed plus A4 x to the 4th plus A5 x to the 5 and so on, right? So from our calculation, this one didn't survive, this didn't survive, A3 didn't survive, A4 and 5 we got it. So hence our solution is A0, which was 12, and then we had A4, that's minus 1, x to the 4th, minus A5, that's 4 over 10, which you can just write it as 2 over 5, x to the 5th, and so on. So that's 3 non-zero terms, the first 3 non-zero terms. Okay, so any questions on this? All right, so any other questions, guys?
Could we do 8b?
Okay. 7, 8. All right, so for part B, I'm going to need your answer for part A.
Then can we do all of 8?
Okay, so let's do all of A.
Wait, Professor.
Yeah,
I have the answer for part A.
you have the answer. Oh, great.
Yeah.
Let's take it.
Okay. y is equal to c1 plus c2t plus c3t squared plus c4t cubed plus c5 cosine of 2t plus c6 sine of 2t plus c7 t cosine of 2t plus c8 t sine of 2t.
Okay, looks good. All right, so how did you get to this answer?
Well,
I can't hear.
Yeah,
hello?
Sadia, I think you got cut off.
Could you hear me now?
Yeah, now it's good.
Okay, so if you look at it says like higher nth order differential equations, right? So we have to first write it in terms of like characteristic polynomial, and if you do that, you're gonna get r to the 8th plus 8r to the 6th plus 16r to the 4th. You could factor out a r to the 4th, and if you do, you're gonna get r to the 4th plus 8r squared plus 16 is equal to 0. And then you could factor out the second part, which is r to the 4th plus 8r squared. So that would be like r to the 4th. Okay, r squared plus 4, and then r squared plus 4. Yeah,
Okay,
and r to the 4th.
so there you go. So you have this factored, and now you just collect all the roots. So the first one gives you r equals 0. So that's repeated 4 times.
Yeah.
That's how we got this one. And then r squared plus 4. So that gives you r is
It's
equal
gonna give you a
to,
complex solution. So like r is equal to plus or minus 2i,
Mhm.
and then again r is equal to plus or minus 2i is repeated.
Right, so this one is repeated twice. All right, so now that we have the homogeneous solution, now let's figure out the form of the particular solution. So we have a linear, we have linear times exponential, negative 2t, and then we have exponential times cosine, and just a constant times sine. Okay, so let's call this one yp1. Let's call this one yp2, yp3, and yp4. So yp1. So we need a first degree polynomial. Let's call it at plus b. Now, let's look at our homogeneous solution.
You have to multiply by t to the 4th.
Right? T to the 4th, because we have up to t to the 3rd on the homogeneous solution. Now, to make it independent from this, we do t to the 4th. And then yp2, that's going to be, again, first degree polynomial. So let's call it ct plus d times the exponential e to the negative 2t. Now, do we have to modify this one?
No.
No, this is good. yp3. So we need an exponential times cosine and sine. So let's call it e to the t cosine of 2t plus f e to the t sine of 2t. Do we have to modify? No, right? It doesn't look
No.
any of the homogeneous terms, so that's good. And then yp4, the last one, we need a constant times sine and cosine. So let's call it g times sine of 2t plus h times cosine of 2t. Do we need to modify this?
Yes.
By
Yes.
what?
T squared.
T squared. Because if you do t, it's going to repeat it with this one. So we do another t, that would be t squared. And then putting all of these together, you will have your yp, which is the form of the particular solution. This question calls it y of t, That would be yp1 plus yp2 plus yp3 plus yp4.
Professor,
Yes.
when we write the answers, do we distribute the negative?
It's up to you if you want to distribute them out or not. Wait,
Because
hold on.
in
What do
the
you mean the negative?
if you look at the right side of the equation,
Oh, you mean these?
yeah.
Well, that's just like a -1, right? It's just a constant.
Okay, we could just ignore it, right?
Yeah, you can all ignore those. They come to play a role when you're actually solving for these unknown coefficients.
Okay.
Yep. All right. Any question, Greg?
Yeah. Would you mind explaining the first four roots? They're all zeros, but they have an ascending order of function t. Is that what it's supposed to be? Because I was under the impression that it would have just been four constants.
So if you make it 4 constants, then you really have one solution. You don't have 4 independent solutions.
Right.
So if you want independent solutions, which is what we want, it's linearly independent.
Okay.
So to make them all different, you modify them by multiplying by t.
Ah, gotcha.
Yeah.
Is that so? Either way, it's technically correct, but in order to deal with this specific problem, you need to use that method.
Right, because you will always want linearly independent solutions.
Okay.
Yeah. All right, so there you go. That's number 8. All right, so any other questions, guys? How do you guys feel for this test?
Professor, one question. Are you going to post this tonight?
I'll put up the video, but not the notes.
No problem.
Yeah.
Professor,
Yes.
could you go over question 5?
Question 5. Right, so that's the Fourier series stuff. Okay.
Yeah.
So do you want A and B?
I have the answer, but I'm not sure if it's right. That's the thing.
Okay, so you want to check.
Yeah.
All right, so let's do it. So we want to find Fourier sine series. All right, the usual, right? You're going to do an odd extension if it's sine. If you're looking for cosine series, you'll do an even extension. So we want to find Bn because we know A0 is 0. An is also 0. So what is that going to give us? So we know we have, well, what is L, first of all? L is
4.
4. So we can always get it from the interval. So we have Bn, that's going to be the integral of negative L to L, f of x, times sine of n pi x over L dx. And because f of x is an odd extension and sine is odd, we can double this integral. So we have 2 over L, L is 4, integrate from 0 to 4. So f of x is going to be, so I'm going to go ahead and distribute the x right here. So we have 4x minus x squared and sine of n pi x over 4 dx. And then we're going to integrate this by using the quick tabular method. So we pick a column for the derivative, we pick a column for integration. So we're going to differentiate 4x minus x squared, and we're going to integrate sine of n pi x over 4. Okay, so now if I differentiate the left side of this column, we get 4 minus 2x. If I differentiate again, I get negative 2. If I differentiate again, 0. All right, now on the right side, we integrate. So we get negative 4 over n pi cosine of n pi x over 4, right?
Mm-hmm.
You integrate again, you get negative 16 over n squared pi square sine of n pi x over 4. I integrate again, I get cosine. Oh, well, let me write the coefficient first. So 16 times 4, 64. And that will give us n cubed pi cubed times cosine of n pi x over 4. So double check. Do they match what you have?
Yep.
Okay. Perfect. Now we cross them in this direction. And then we multiply them with plus and minus. Plus, minus, plus. Okay. We're ready to write this down now. So carefully, let's write this out. So all of this is equal to, so 2 over 4, that's just 1/2. And then we have negative times 4x minus x squared times 4 over n times pi times cosine of n pi x over 4. The second one we have, so we have double negative, so that will become plus. So we have plus 4 minus 2x times 16 over n squared pi squared times sine of 4, sorry, not 4, n pi x over 4. And the last one we get is a minus 2 times 64 over n cubed pi cubed times cosine of n pi x over 4. And we're going to evaluate all of these from 0 to 4, 0 to 4, 0 to 4, and everything gets a half. So let me just put this on the side. All right, so that's a really long problem. All right, we can do it. All right, what do we get? Well, which one survives?
You see the negative 2 times 64 over n cubed or pi cubed?
Yeah.
The third part, that survives.
So Sadia says this one will survive. So let's check it out. If I plug in 4 into the first term, so plug in 4, the upper limit, 16 and 16 goes to 0. Plug in 0 goes to 0. All of it goes to 0. Second one, if I plug in 4, sine of n pi 0, plug in 0 goes to 0. Yep, absolutely. So the last one survives. Yay. Okay. So we have 1/2 in the front times. So I'm going to do little simplification. So we have 64 times 2, that's 128. So I have negative 128 over n cubed pi cubed. If I plug in the upper limit, I have cosine of n pi. And we know from memory, cosine of n pi is negative 1 to the n. Plug in the lower limit, so that gives me a plus sign. And 128 over cosine of 0 is 1, so that's n cubed pi cubed. And now we can break this into cases because looks like we have 0 bn that we're adding up as we let n run from even numbers to odd numbers. So if we have even values for n, then all of this goes to 0, right? So we get 0 for if n is even, and then we get 2 times 128 over that. So that would give us just 128 over n cubed pi cubed if n is odd, right? So I combine like terms. And there you go, we have our coefficient Bn. So to write it out nicely, continuing over here, so our Fourier series is going to be the sum where n is odd right? So we could just write n odd. N starting from 1, but it's odd, to infinity bn, which is 128 over n cubed pi cubed times sine of n pi x over 4. That would
Professor,
be, yeah.
would it be wrong if I wrote 2n minus 1 inside the n?
Oh no, that's absolutely right too. So, or if you use the rule for odd numbers, you'll have f of x is equal to the sum n equals 1 to infinity. So you don't have to write odd with the summation. You just plug in the rule for odd numbers, 128 over 2n minus 1 cube pi cube times sine of n, well, n is 2n minus 1 pi x over 4. So if you use the rule for odd numbers, you can express it this way. If you don't, then you have to write in the summation n is odd. Any of these are fine. Now, taking this coefficient bn, we can fill in the heat equation, right? So for heat equation, all you do is kind of write down the general solution. So we know our solution, uxt, is going to be the sum n equals 1 to infinity. Now, because bn happens to only survive for odd values of n, we also need that for this part as well. So we have bn, which is 128 over n cubed pi cubed e to the negative. So what was that entire formula? Negative alpha squared.
Alpha squared.
Well, we need to
N
figure out
squared.
alpha squared, right? So this
Alpha is
would,
1/3, isn't it?
right, so ut is equal to 1 over 3 uxx. So make sure you write it in this form and then determine what is the value for alpha squared. So that's 1/3 in this problem. So this, we would have alpha squared, that's 1/3. So alpha squared, n squared, pi squared, L squared, L is 4, so that's 16, T sine of n pi x over L, which is 4. So that's one way to write the solution to the heat equation, right? Now, if you want to write again n is odd, you have to modify it. You would have to plug in the value for odd numbers. So you'll have the sum n equals 1 to infinity 128 over 2n minus 1 cube pi cube e to the negative 1/3. And of course 16 and 1/3, you can combine them too. I'm just not writing it. 2n minus 1 cube pi square. Hold on, sorry. Why do I have a cube there? It should be square. N square pi square times t over 16 sine of 2n minus 1 pi x over 4. Or that, right? So you can express it either way. So just know both, just in case if one of them doesn't happen to be a choice, the other one would be. If not, you know, you know what to do. So,
Okay.
Yeah. Did it match your answer?
Yeah.
Okay, good. All right, so we got it. All right, so it is 6:50. 10 more minutes, unless you guys are all doing great. So, any other questions or?
Professor.
Yeah.
For question 10b, right?
Okay.
The last question. I got how to do the part A. For part B, when it says define the Wronskian of the pair y1 and y2, do they just want like how we get the Wronskian?
Hold on. Okay, so define the Wronskian of pair of y1 and y2. Just the definition.
Okay.
Yeah, so what was the definition for Wronskian?
It was y1 and then y1 prime, y2 and then y2 prime.
y2 prime. And then we would have y1, y2 prime minus y.
y2,
Mhm.
y1 prime.
Yeah. Definition of the Wronskian.
Do we need to write when we get the fundamental solutions and when we don't get the fundamental solutions for part
That's
B?
right. So part B.
Part
no.
C is that. Part C is that.
Yeah. Part B. No. Part B. You just want to state the definition. That's it.
Okay.
Yeah. So it's important to know the definitions. All right. So I'm gonna stop here. Do you guys have any other concern, questions?
I have a question about B of n
Okay.
and the answer for it. So if B of n is that whole function, and then for the heat equation, you take B of what equals B of n and you put it into the summation of B of n times the exponential function times the sine function again.
Mhm.
Why is it that the sine function isn't squared if there's a sine function in the B of n value?
Well, the sine function is not in B of n, right?
It's not. Okay.
No, it's, so if you look at it, this is the Fourier series. This is part of the Fourier series. And this is the only Bn.
Got it. Okay.
That's the only Bn portion. And we define Bn by this integral right here. Right?
Mm-hmm.
Yeah. All right.
All right.
Okay.
Thank you.
Yeah, no problem. All right. So I hope all of you do well on Thursday. I'll send out an email to the class tomorrow. That way you know what to do on Thursday. So the exam will be from 5 to 7:15. It will become available to you around 4:50-ish, I think, or 4:55. I haven't checked the time yet. But 5 to 7:15 is when the exam will start and end. And then after you finish the test, you'll drop in your exam work on Dropbox through the link, just like you've been doing for the exams for me.
Are there
Okay. Andrew?
any more topics or that you think might be on the test in addition to?
It's cumulative. So you have to study everything from beginning to the end. So I wouldn't focus on just one thing. I would focus on everything. Yeah, it's a cumulative final.
Okay.
Okay. And the best way to prepare is to redo the exam questions that you saw from me. Do the past final exams that are posted on the department website and our class notes, right? So go over those materials again and then see which topic you need help with most. If it's chapter 10, do more on chapter 10. If it's chapter 7, do more on that. And we'll even do 7, sorry. Did we? I don't remember anymore, but it's over. So after Thursday, it's over for you guys. All right.
And then also, when do you think we might have our test grades up?
For exam 2. Let's say tomorrow. I will do my best to finish up. I still have a few more to go through. And it's just taking me so long because some of you didn't scan it the way I wanted you to. So I have to go through every single question and they're not in order. So it's taking me more time than usual. But I will try my best to get it done before Thursday. So sometime tomorrow night, I'll send out another email for exams if I finish grading. So you'll have that as well.
Thank you.
Yep. All right. Any other questions, guys?
Thank you, Professor. You've been great.
Yep. No problem. All right. I wish you guys all the best and do well. Keep studying. Email me if anything, and we'll see each other on Thursday. So try to come early. Come around like 4:45-ish, right? Doesn't hurt to come 10 minutes early, 15 minutes early. And then we'll start the exam exactly at 5. I will see you guys. So I'll be proctoring on Blackboard. We'll have our session in Blackboard, just proctoring session the usual way. And you'll be taking the exam on Blackboard. So I'll be there just in case you guys have any technical difficulties or any questions or anything.
Professor.
Yep.
Do you know if the math courses are going to be online for the next semester?
I think they are. I'm not sure. But I'm 90% sure they are.
Okay.
Yeah, we'll find out, right? We'll find out later. All right, so you guys are good to go. Enjoy your summer. I will see you all Thursday. And keep studying and keep working hard.
Take care, Professor.
Thank you. All right, you guys have a wonderful one.